Next up in our review, we've got question 9 asking about the trig ratios. So pretty standard, although as I'm starting the video, I'm realizing this this image is not exactly complete. In fact, we're missing the number 36 here. We're missing X, circle around it, and Y. But that's good enough. Okay, moving on. Find the following trig ratios for X. So that's why we circled X. Okay, so what we're looking at for X is the sine ratio. Sine is opposite over hypotenuse. Opposite over hypotenuse. Nope, said that wrong. Okay, maybe I need to take a break on these. Hypotenuse is right there, so 15 over 39. Cosine, that's going to be, next color, sure. Cosine is adjacent over hypotenuse, so 36 39ths. And tangent, let's find another color. Hey, that looks good. Tangent, that is opposite over adjacent. So that gives us 15 over 36. Now, cosecant, secant, cotangent, I have had some students getting these mixed up, so let's be careful here. Cosecant and sine, those are the ones that have the reciprocation. So the reciprocal of sine is cosecant. It's not a matter of the s in sine is matching the s in secant. That's actually quite the opposite, and that's what makes it easy for a lot of people to remember which one goes with which as reciprocals or inverses, is that the sine has an inverse of cosecant. They're kind of opposites to some degree in terms of what you're doing with the fraction, so maybe you think of the s in sine and then the c in cosecant go together because they're like the opposite letters. So I don't know. It's up to you how you know it, memorize it, but for sure do not memorize it as the s in sine and the s in secant go together. So with that said, the cosecant ratio, we're just going to flip that sine ratio and say 39/15. Same with secant. Secant, we're going to take our cosine and we're going to flip that around. We're going to call that 39/36. And cotangent, same thing. We're just flipping everything. So there it is. That's question 9. Let's move on. Know your unit circle. Not going to lie, I'm not going to do the unit circle. For one, I could probably do just a separate video on that altogether. But at the same time, it's not a problem number on here. So yeah, maybe that's what I'll do. I'll just do a whole video on solving the unit circle, and so let's do this. If you are not fully confident in your unit circle skills at this point before question 10, take a pause on this video, go back, find my video for solving the unit circle. Hell, find somebody's video. I'm not saying I'm the only one that has a good video on it. In fact, I'm not even saying mine's good. I'm saying if you don't feel confident in filling out a blank unit circle right now, pause, find some way of learning that. Go to YouTube, go to your friends, find a way to solve the unit circle first, then come back and then we can talk questions 10 through 35. All right, so again, I'll take a pause, give you a second, and then when you're ready, find this spot. Mark that. It looks like we're just over 4 minutes, and we'll come back to these problems. Okay, as we look at this set of questions, there should be a break. I do apologize. I didn't notice this at first. There should be a break right here. I'll do it in bright red. But there should be a break right here where we say find two solutions. So 28 through 35, you're being asked a whole different type of question than 10 through 27. So again, I'll just preface it with that. Question 10, sine of 45 degrees. They're asking what is the ratio, kind of like we solved up here, where we had a particular triangle with particular side lengths. We want to know sine of 45 degrees. Well, in the unit circle, 45 degrees, we look at those xy coordinates. Okay, so if you have a unit circle filled out and you look at 45 degrees, you have the xy coordinates of square root of 2 over 2, comma, square root 2 over 2. Fantastic, right? What do we do with that? Well, sine is, well, if I drop that leg down, sine of this angle 45 is the opposite right here, which is, let me do this instead. There. Square root 2 over 2 is the side length, and then in the unit circle, that hypotenuse is always 1. Thus the name unit circle, we have 1 unit of radius. So sine is opposite of hypotenuse, so your answer is just simply the square root of 2 over 2. Let me box that in. Tangent 5 pi over 4. Nope. Sorry, I'm going the wrong way. I don't know why it's numbered weird. Numbered in columns. But anyways, number 11, cosine 0. So cosine of 0, here's my, and there's my angle right there. It's really just the straight line x-axis, right? So what is the xy coordinate? The xy coordinate is 1, comma, 0. Well, cosine in any triangle on the unit circle, let's say we went up more than 0 degrees, but if we did that, cosine is going to be this adjacent side. I'm going to call that A for adjacent. Adjacent over 1. In this case, the adjacent side length is 1. The hypotenuse is 0. So our answer for cosine of 0 is just the x value, or 1. Sorry, I don't know why I circled that one and boxed the other one. There. Boxed it in. All right, then we keep going. Tangent of 30 degrees. All right, well, tangent of 30, I might need that unit circle. So let's take a look at that unit circle. There it is. The tangent of 30 degrees. Okay, well, here's 30 degrees right here, right? So my triangle, if I drop a line straight down, I wish I could edit this. Draw on this, I should say. But, okay, so let me recreate part of this. All right, so my unit circle is kind of coming through like this. And the thing is, we've got 30 degrees, and it's calling it root 3 over 2, comma 1/2 is what the unit circle says. What that really means, let me zoom in for a second. What we're trying to say is simply take a look and imagine drawing a leg straight down. There's 30 degrees. So if I were to know that my radius is 1, so my hypotenuse in the unit circle, that's 1. The distances of my x-coordinate, it's telling me I had to go over square root 3 over 2 and up 1/2. That's how I got to this point. So if I do that, I'm just being asked, what is the tangent of 30 degrees? The tangent of 30 degrees is taking the opposite over adjacent. So it's asking me to take the opposite, 1/2, over the adjacent, square root 3 over 2. We can't just leave that. We can't leave a fraction over a fraction. That's not a simplified enough answer. We have to take 1/2 times the inverse fraction, 2 over the square root of 3. So when you multiply fractions, you take 1 times 2, you get 2, and you take 2 times the square root of 3. Well, the 2's just cancel each other out, and you're left with 1 over the square root of 3. And that's your answer. I think we got it covered, right? I do know that I've got another video, as I had said before, on the unit circle to help. But in the end, there's 2 triangles you really need to know. And if you can get these 2 triangles memorized, you're set for all of these problems. Those 2 triangles are the 30, 60, 90. So a 30, 60, and then 90 triangle. In the unit circle, we say that this hypotenuse is 1, this is 1/2, and this is the square root of 3 over 2. Now you can put that triangle anywhere in the unit circle. Let's take a quick look at that. I can look at it and see I've got a 30-degree angle right here. If I drop this line straight down, I have a 30, 60, 90 triangle. If I have a 60-degree triangle, if I have a 60-degree angle from the origin, first of all, it's called pi over 3. It's also 60 degrees. But if I have that coordinate point on the unit circle and I draw a line straight down, that line creates an angle at the top, 30 degrees, and then an angle down here of 60. So we still have a 30, 60, 90 triangle. What changes is my x coordinate to get to the point on the unit circle. If I drop this straight down, then the x distance is 1/2, and then the y distance is the larger one. See how much higher I have to go to get there? So no matter what, my 30, 60, 90 triangle has square root 3 over 2 for the longer side and 1/2 for the shorter side. It's just a matter of what direction my triangle sits. Let's go over here to 150 degrees. Well, if I look at 150 and I drop a vertical line straight down, my y distance is 1/2. Take a look, 1/2. If I look at the x distance that I had to take to get to this point, that x distance from the origin here, that's negative square root 3 over 2. So I still have a 30, 60, 90 triangle. I've just placed it in the second quadrant. So I'm going to do that over and over and over. Like here, I've got another 30, 60, 90 triangle. I'm going to draw a line from 240 degrees. I'm going to draw that straight up to here. And now I have back here a 60-degree reference angle. And then from here around, I've got 30. So again, I'm 30, 60, 90, and look at my numbers. They're still 1/2 and square root 3 over 2. What happens is I'm in the third quadrant, so my x direction from the origin was negative. My y direction from the origin is negative. So my coordinates just change their signage from positive to negative. That is going to allow me to answer pretty much all of my questions. Now, I've only done 10, 11, 12. I will stop this video because it's kind of a sub video that I've went on a tangent of solving the unit circle. But pausing there, I will answer the rest of these problems.